Hey guys, Mr. Gibson here again. I'm going to show you guys in this video how to solve multi-step inequality. So an equation is an equality. These are equation-like expressions that are inequalities, okay? So first let's have a general discussion of how to read inequalities. And I say read inequalities like you're reading a sentence. So here I have x, here's this sign, that sign means is greater than. Here's that number is 5, so I can read this as x is greater than 5. So the trick to this is to start with the x side when you read a sentence. The sentence should always start with x. So listen to this carefully. I have x right here, so my x is on my left side, so I'm going to say x, and look, I know you might say to me, well, Mr. Gibson, that is a greater than symbol. You are right. But if I'm taking it from the perspective of the x, it's a less than or equal to symbol, okay? So x, look, it's pointing towards the x, so it's x is less than or equal to 15. So start with the x side. And you'll see why that's going to make it easier in a moment. Okay, the other thing we're going to have to talk about too is number lines, okay? Because these will be important for our answers to these problems. Okay, so this is x is greater than 5. You use an open dot at the number that's given here if it's a just greater than or less than symbol, okay? That's because if it's not equal to, it never actually reaches the number 5. It gets as close as it possibly can, but it never actually reaches it. So x is greater than 5, so open circle, and greater than means I go to the right, okay? Again, to this problem, I'm going to start with the x, okay? X is less than or equal to 15. And you're going to see here, it makes it a little easier to draw our number line. This is an equal then, so the x value is actually going to equal 15, so we're going to put a closed dot right there, okay? So open dot for no equals. If there's an equals here, you're going to put a closed dot. Less than, that means you're going to go to the left, so x is 15, less than to the left. That's why we have to read it as a sentence. Okay, now to solving some inequalities. And you guys, if you really understood the solving multi-step equations, this is going to be fairly simple, okay? So look, this is, I'm going to read it almost like an equation. X plus 2 is greater than 3. I'm going to treat it like x plus 2 it equals 3. I'm going to isolate the variable. I have a plus 2, so that means I'm going to subtract 2 on both sides using my opposite operations. Okay? X plus 2 minus 2 is just x. X is greater than 1 because 3 minus 2 is 1. Alright, great. So I'm going to do a open dot here. Okay? And it's greater than, so I'm going to point to the right. And this number line represents my answers, okay? Everything from this 1 to the right is a possible answer to this inequality, okay? Here's another more complicated problem. It's x, so I'm going to start with that. X over 3 minus 2 is less than or equal to 7. I'm going to treat it like I treated the variable on the left-hand side with the equations. And I'm going to just go ahead and flip the equation around. So this is going to be x over 3 minus 2. It's still, look, less than, so I kind of flipped the sign, less than or equal to 7. Treat it like a regular equation here. I'm going to add 2 to both sides. Okay, that's 7 plus 2 is 9. The minus 2 and plus 2 equal 0, so those cancel out. I have x over 3. X is being divided by 3. So I'm going to multiply 3 on both sides. Okay, terrific. And I get x is less than or equal to 27. So close dot at the 27. Okay. Less than means go to the left. Okay. So those are a couple multi-step inequalities. The only thing you really treat differently is you're going to have to account for that less than or that greater than sign at the end of this equation. So for a couple more problems right here, just a few little special cases, And this is probably the toughest thing. This is what we're going to have to remember, okay? So, I have x minus 3 is greater than 21, okay? Well, I'm just going to solve this by dividing negative 3, because it's being multiplied by negative 3, so it's the opposite operation as negative 3. Negative 3 over 3, negative 3 is positive 1, so you get 1x, or just x. 21 divided by 3 is 7. Now, here's the important part. If you ever solve by dividing or multiplying, you have to flip this sign, okay? So this greater than sign is going to become a less than sign, okay? So if you're ever dividing or multiplying by a negative, you have to flip the sign. All right, x is a less than 7, so I'm going to put an open dot right here, and I'm going to go to the left for less than, okay? All right, so this next question, negative 5 times x plus minus 2 is less than or equal to 4x plus 1. I know in the earlier video I had said, hey, if you have a number outside the distribution, to go ahead and divide it. In this case, it'll actually make it a little harder. Okay, it'll actually make it a little harder. So I went ahead and I distributed. Okay, so I have negative 5 plus 10, because negative 2 times negative 5 is plus 10, okay? And it makes it a little harder because I have a variable on the right side. But like the last equations video that I showed you guys, I have variables on both sides. I'm going to move the variables to the left. So that means I'm going to subtract 4x on both sides. Okay, 4x minus 4x is 0, so those cancel out. Negative 5x minus 4x is negative 9x. So negative 9x plus 3 is less than or equal to 1. Okay, so I'm going to subtract this 10 on both sides. 1 minus 10 is negative 9. I have negative 9x is less than or equal to negative 9x. Well, that's the x is being multiplied by negative 9, so I'm going to divide negative 9 on both sides, and I get x, negative 9 divided by negative 9 is positive 1. But remember, I had less than or equal to, so what I have to do here is flip the sign, so it'll become greater than or equal to, okay? And sometimes we won't ask you guys to write the number line, and in this case I won't. So thank you guys for your attention.